of their own. They talk about taxing firms. We're not going to tax people. No, we're not taxing people like you. We're just taxing firms, corporations. Right? And in their pattern, it must be that somehow the shareholders of the corporation pay all the tax, and none of it gets passed to the consumers. And we'll get to look at that one, too. And so as we do these examples, ask yourself in each example and in each example of the homework, if things were set up this way, which one of these two beliefs would really be right? So stick that away in your brain. There are two types of taxes. Ad valorem taxes, which are like a sales tax, 9%, 9.5% in Alameda County. That's called ad valorem, percent of value. And it doesn't lead to as clean graphs, and it doesn't help you understand what's going on any better. So I'll choose the simple case, if you don't mind. The simple case is a specific tax, so many cents per gallon for gasoline, for instance. If you look at gasoline taxes, you have both types, but you certainly do have the federal tax on gasoline, federal excise tax on gasoline, which is like 20-something cents a gallon. It has been forever. So that's a specific tax. It's a price that you have to pay per unit sold. We need a little more notation to make this work nicely. I need to not just have price. I need to be clear about two different prices. The price the consumer pays, I put D for demand, and the price the supplier gets, I put S for supply. With a specific tax, they're different by the tax. That makes sense. You pay $1.07. The store keeps $1. 7 cents goes away to the government. Right? So in that example, you paid 107. The store got 100. The government got 0.07. So these two prices have to be different if there's a tax. That's what a tax does. It drives a wedge between what the consumer pays out and what the producer receives. That's the point of it. Well, the point of it is to make money, but we don't need that quite yet. So producers respond to what they receive, right? So now when I write the supply curve, I have to be careful to write it in terms of the price they receive. Consumers purchase according to what it costs. And these things are not the same. You know how they're related. So you have to have quantity sold is the same as quantity purchased. So those two things are equal, but the two prices aren't equal anymore. You have this. You really have just two equations in two unknowns, and you could solve them. And that's exactly what we'll do. So let's go for some algebra. So the first line says the quantity sold equals the quantity purchased. Yeah? That makes sense. The second one is just our conservation of money law. The amount of money laid out equals the amount that the producers get plus the amount the government gets. That makes sense. The objective now is to solve the two equations for the prices PS and PD. So an obvious solution technique is just to substitute in for one or the other. So here I've taken D as a function of PD, but what is PD? It's PS plus D, and I shoved it in there. So I have a formal solution. So if I actually had an equation for this, I could solve it for PS. As soon as I solved it for PS, I could add T to it and I'd solve it for PD. So that should not be very hard. So let's take an example. So here I have Q is 3PS for supply curve, right? And I have demand curve, Q is 12 minus 4 PD. It's the same one I had last time. And in the no tax equilibrium, T is 0, so P equals PS equals PD. They're all the same. And this was exactly our example for last time. If you solve those two equations, you will get Q is 36/7 and P is 12/7. And the stars typically mean this is an equilibrium value. It's my solution value. So if I say P star or Q star, I solve for something, this is the answer. I guess you could solve that fast enough. You take the Q on the second line, write 3P, and take the P's over to one side, and you'll get it. Now let's do the same thing with the tax. So I'm going to have a tax of 2, and now I have 3 equations. I got, let's see if I have to tell this to, let's tell this to be a pointer again. Come on. Okay, so I got my first equation. This guy is the demand curve, right? My second equation is the supply curve. And my third equation down here is the tax identity, the conservation of money tax identity. I just want to solve 3 equations and 3 unknowns. That's all I want to do. Well, the way that I'd like to do it is I'm going to get rid of PD and do everything in terms of PS. That's easy because I have an equation for PD. So here I have 12 minus 4 PD, which is nothing more than PS plus D, right? So that's one substitution I've done. And then since the Q's are the same here, this Q is this Q, I make it equal to PS. So this is both doing supply equals demand. That's what equal sign is. And I'm using this to substitute in here. Now I got it down to one equation in PS and T. I know what T is. T is 2 in the example. So I could put in the 2, and then I can carry out the algebra. And if I carry out the algebra, I'll get P is 4/7. PS is 4/7. PD is 18/7. Can you tell immediately that those are plausible? Yeah, because PS plus 2 equals PD, and 2 is the tax. Right? So it's not obviously wrong. Can we do it in a graph? Well, here's the trick of the matter. It's that if you start by getting the inverse functions, you can get a much easier way to see it in a graph. So step 1 is instead of writing Q is 12 minus 4 PD, I want to flip it around and write PD is 12 minus Q over 4. Right? I have the function with the P on the left. I do the same for the supply curve. P is Q over 3. So I've got the same exact functions, but I just put P's on the left-hand side. Now, why is this going to help me? So let's look and see. So I have my supply curve, my demand curve, I have my supply curve. And what's the equilibrium now? The equilibrium is the price on the demand curve, right, equals the price on the supply curve plus the tax. Well, the price on the demand curve is the inverse demand function. The price on the supply curve is the inverse supply function. And depending on how you want to set this up, you can either add the T or subtract it. Here, I'll subtract it. So take this line, take this T over here. So now I got the inverse minus T, right? So moved it over to the other side, equals PS. Right? That's what it should equal. And PS is the supply curve. So now look what I got. I've got the demand curve minus T equals the supply curve. That's my equilibrium. Well, that turns out to be very easy to draw. Why? Because I've got a curve. Right? D inverse is a curve, some downward sloping thing, which I'll show you in a minute. And what does this instruct me to do? What do I do to that curve? What's that going to do to that curve? Yeah, it's going to shift it. So it's just going to look like a standard shift. It's going to shift it down by exactly t is what it's going to do. Okay? So I'm going to have a demand equals supply diagram, and then I'm going to be able to solve it by just taking the demand curve and shifting it down by the amount of the tax and reading off the new equilibrium. That's what the algebra told me to do. So here it is graphically. Right? So here's my old solution, and it matches the one I gave you. Here's the new solution. It too matches the numbers I gave you. And all I've done is I've shifted that balloon line down by exactly 2 and then found where they intersect. Now you can talk it through a lot of different ways. One way is this. This is the supply curve, right? Inverse supply curve. So for any quantity, it tells you what price the producers will need to be paid for them to make the quantity. Up there is the demand curve, the blue thing. That tells you what price, that tells you as a function of quantity, the price that you'll have to charge to get the consumers to buy exactly that quantity. But the new piece is that if you pick this quantity here and you ask, how much will the consumers pay? It's 2.5. But of that 2.5, how much will go to the producers? 2.5 minus tax. So at a quantity of around 2.5 gets laid out by the consumers. 2 of it goes away to the government. And the amount available to pay the producers as a function of quantity is now the green line, like a path at this point. So this line is, given the demand curve and given the tax, for every quantity, how much of the price is left for the producers. And then the amount that's left for the producers and the producer supply curve intersect at the equilibrium. That's probably the way to talk that through. So now you have it algebraically and you have it graphically. Your problem set walks you through a large set of cases. You now know, I believe, enough to do the problem set. And let me just put on the board what some of the supply curve demand curves could look like. First of all, you could have something that looked like this, and you're used to that. But that's possible, and that's possible. So when you go through the problem set and you see a supply or a demand curve, and it doesn't look like it fits that pattern, the reason why is it doesn't. Some of the curves fit this pattern, and some of the curves fit that pattern. So this is quantity, right? So this would be, an example of something like this is Q equals 3. It's a legitimate curve. You want to write it out so differently, you could write Q equals 3 plus 0 times price. Okay? Now it looks like a demand curve. It's still Q equals 3. This obviously you could write as P equals something, right? And again, you write an equation for it by just adding plus 0 times Q if you wanted. So these are legitimate curves, as is this one. And problem set makes you look at some of these extremes, because these extremes show you what happens to the tax incidence, which we will come to in a few seconds. Right? So now you need to know the one last thing that you need for the problem set, and that is all 3 of these possibilities will appear for either demand or supply, but not both. Okay, so let's go on with our example. So you could do this in the other direction. You could just do the substitution in the other direction. Same thing I had before, right? Supply price equals demand price minus tax. Now I could take the t and add it onto this side. So to take the supply curve and add the tax to it, shift it up by the tax, make that equal to PD, which is equal, of course, to the demand curve. So there are 2 ways to solve. One way is shift your demand curve down by the tax. The other way, shift your supply curve up by the tax. Sometimes one is convenient, and sometimes the other is convenient. It's just a matter of convenience. They have to give you the same answers. Why? Because there's only one set of equations, and all we've done is make our substitutions in a different order, and that's what gives us a different looking graph. It's just which thing we put where, but there's no separate algebra. In many economics courses, people make a big deal out of this and say, see, it doesn't matter whether you state the tax as a tax on the producer or a tax on the consumer, which obviously has to be true. It makes no difference whether it's Europe, where the tax looks like it's on the store. When you go and you buy a quart of milk, a liter of milk, in Sweden, there's a price. That's the price you pay. The sales tax is in it already. So it looks like, quote, the store is paying the sales tax. You buy a quart of milk in the United States, there's the price on the shelf plus whatever tax you pay. So it looks like you're paying the sales tax. But the algebra here is exactly the same. It makes no difference. You get the same price and the same quantity at the end, whether you state the problem one way or the other, or whether you shift one curve or you shift the other curve. And if you don't think that's true, take one of the examples and shift one curve and then the other curve. Just do it on a piece of graph paper, freehand. Just get your curve shifts to be the same number of inches. You don't need graph paper. You do it on a piece of notebook paper with a ruler. And you'll discover that you get exactly the same prices, and therefore you get exactly the same quantities. Before I give this away, is anyone didn't sign up? Well, okay. And then pass it out that way, and then there's someone in the back. Pass it to them, and then back down. Okay, so we'll be done with that. So you can do this either way. You get exactly the same answer. It's just up to your convenience how you solve it. And it's literally, what thing do I substitute out? Do I get rid of PD or do I get rid of PS? And here's the same thing with the supply shifting. And lo and behold, you come to exactly the same quantity, same price for the producer, same price for the consumer. And they're always 2 apart. When you have a tax, you're going to see, if you have the lines, both the lines have slope, nobody's standing up, nobody's flat. Okay? Both the lines have some slope between 0 and infinity. You're going to see that the price to the consumer goes up and the price to the producer goes down. The amount by which the price to the consumer goes up is the consumer's tax incidence. The amount by which the producer's price goes down is the producer's tax incidence. When you add the 2 together, they come out to the tax. So the question is, what is the tax incidence and what does it depend on? Well, first, remember, this is the no tax price. So what we're doing is we're comparing the price with no tax to the price that results with a tax. Let's just go back. So the no tax price is right around there, right? The with tax price, there are 2 of them. There's that intersection, which is the price for the consumer, right? It's the price PD, and there's this price, PS, and they differ by the tax. Well, if you compare the no tax, here we are, P star, and the with tax, the difference between the two is the amount of the tax incident on the consumer. Here it's, I don't know, a bunch. Then if you compare the original with the price after the tax, you discover this distance, the amount incident on the producer. Yeah. No, because, oh, it only applies at the equilibrium, yeah. Right. You have to read it at the equilibrium. There is only one equilibrium price without the tax, and there's only one equilibrium price for each agent with the tax. So yes, it has to be at the new equilibrium, where supply equals demand up here. Right? So start from the beginning. I draw demand and supply curve. They cross. I find the P. There's a Q that goes along with it, but I don't care about that for the moment. Then I add a tax. The demand curve comes down. The new shifted down demand curve hits the supply curve at some quantity. That's the new equilibrium quantity. But I don't care about that. But I can look and see what's the new equilibrium price for the consumer and what's the new equilibrium price for the producer. And I compare those new equilibrium prices for producer and consumer with the no tax equilibrium. Right? The differences are the incidence on the producer and the incidence on the consumer. Yeah. That's the story. Thank you. Okay, you okay with that? You're going to do this about 9 times after you leave here. So get your questions in before you get into this algebraic morass. So in our example, P star was 12 over 7. The new price to the consumer was 18 over 7. So 18 over 7 minus 12 over 7 is 6 over 7. And that is the amount by which the price rises for the consumer. So 6/7 of a dollar was incident on the consumer. The producer sees his price fall from the original price, 12 over 7, new price 4 over 7. And so he loses 8 over 7. That's incident on him. You add the two of them together, they better add the two of the total amount of the tax. So when you put a tax on in a market where you have the curves that do this, right, you're going to find that both people see a change in price. Some of the tax is incident on the consumer, some is incident on the producer. That's the way it is. In your homework, you'll find some other interesting cases where all is incident on one or all is incident on the other. That's what the other cases are. Okay, so just make sure you can do your homework. It says, draw a demand curve and a flat or horizontal supply curve. So draw me, right, so I want supply like this and I want demand like this, and now put tax on it. And take a couple of minutes. If you can't do it, let's talk about it now. Let's not talk about it at 11 o'clock at night when you have 2 pages of these to do. You all there? You got a curve? You got a shifted curve here by now? So I should be adding a tax. So what am I going to do to D? If I add a tax, what happens to the demand curve? Shifts in, shifts down, because you want it to shift down by the amount of the tax. So I'd say down. Make your life easier. Right? Because this is the amount of the tax. Well, this is a very interesting point right here. Here's the original. What's the new price for the producer? Where do I find it? Is it here, here, there? Where'd it go? For whom? For the producer. And what happens to the price for the consumer? It increases, all right. And it increases by how much? Someone said it. By the whole amount of the tax. Okay. Yeah, it adds up to the tax. And it's completely incident on who? Yeah. So that's an interesting case, is it not? You created a case where a flat supply curve, which you believe if there are many, many, many potential firms, and they have what we call constant costs. So if in the problem set it says the constant cost case, that's what it's talking about. Then any taxes you put on will always be passed through 100%. And you can see why. Suppose the price for the producer went down a little bit. What would they make? Nothing, right? So that can't be an answer. And if it went up a little bit, they'd make infinity, and that can't be an answer. And so you can take this as a first